If you're running A/B tests in email and calling a winner after just one send, your data is probably useless. Here's why most A/B tests in ecom mean nothing and how you can actually make them mean something. A/B tests are one of the highest used tools for people to chase those data-driven insights. It's a beautiful concept. We think, oh, I'm going to send a variation A to group A, variation B to group B, and it's scientific. If I see that one of them is better than the other, that means that thing that I tested, if I only change one thing, that thing must be the winner. And that is the common assumption in e-commerce, and that's how most people set up their A/B tests. And so they will just kind of set it up like orange CTA versus blue CTA, and we change nothing else, and then they'll send it. If they do get statistically significant results in Klaviyo, they will trust that data, because why not, right? You've done everything right. You've tested your CTA, you've isolated one variable, tested it, it's scientific, it has to be true. It's not true in a staggering amount of cases, and I'm going to explain why. But first, if you don't believe that, there's a very easy way to test this, and this is kind of how I got interested in finding out what was wrong with A/B tests. Is you can literally, if you want, set up an A/B test with an exact copy of the other email, testing absolutely nothing, and just see how crazy those numbers can be different. The question is, why is this happening, right? And the answer is you're not actually isolating one variable, because it's impossible to isolate one variable perfectly. There are so many other things that interfere with your test and that you also have to include in your calculation. That's why these calculations are completely wrong. So an example, I'm going to give you a couple. Distribution, right? You will send an email. Let's say you have 80,000 people you send this email to, 40,000 on each side. It's not perfect distribution. You might get people that are further in their purchase cycle than other people, and then you might get people who are high value customers versus not high value customers. Those are usually small groups that have meaningfully higher conversion rates. So if some of them end up more in one group than the other, but it will skew your data. And the statistical significance test is only run on how many recipients there are. So it doesn't account for how many recipients of which segment or what expected value. Klaviyo doesn't measure that at all. So that part is completely left out. And 99% of brands will not have a sending pool that's big enough to be statistically significant in distribution. We can expect that within one send we've hit perfect distribution on average. It's not gonna work. So you might have significant differences in who gets which version, and that will completely imbalance your test without telling you anything about it, right? It will still show you statistically significant, even though actually your data is built on nothing, right? So that is why you get such big differences, even if you test literally exactly the same thing. Honestly, I'd encourage you to do that for fun, just to see how crazy this is. The second thing is you have life factors, right? You might be able to reach people who otherwise might have purchased, but they just got a flow and they just made their purchase, or they've just gotten too many emails and so they're kind of fatigued. It's hard to really evaluate that on an individual basis. And again, this is a population distribution thing where some people who would have otherwise purchased landed in one group and so they didn't purchase. So these tiny little things, there are so many of them, and it's really impossible to correct for all of them. If you do one send, it's genuinely impossible. So these tests that you run, they're not actually doing anything. They're just giving you the false safety of saying, oh, I've tested this, it's scientific, and therefore it's right. Therefore, we're going to run this blue CTA because we did this one test that told us the blue CTA was correct, and so we're going to just use that all the time now. I think the approach is genuinely good. It's a nice thing to want to know and optimize your emails, and it's definitely what you should be doing, but there is a better way to do it. And so this is what I want to show you now. The way that we do A/B tests is the biggest thing is doing repeat tests for us. Even if a test is incredibly clear, like we did this one last year, we tested if SMS messages should have an image or not, and the overwhelming numbers were against images, which is great because they're cheaper. But that's a different point. We wanted to we were testing it, and the click rates and even the conversion rates were 3 times, like 3x from the first send. We were getting a 12% click rate versus a 3% click rate on the image, on the SMS without an image. And so it was very clear from the start this was going to be that this was a statistically significant test. But even so, I still continued testing it at least, I think, 4 or 5 times, just to be really sure that it was actually the image and not some other quirky thing that we didn't think of that was causing this difference. Because once you've sent an email, email or a test 4, 5, or 6 times, then you can really say, okay, I've randomized this enough, right? The populations get shuffled every time, so they might even see different variations of the email and then react to them. And so when we batch all of them, pool them together, look at the result as a pooled experiment, that's when we can really say, okay, the randomness, we've taken the randomness factor out as much as possible, and now we have clean data that account for all these little variables that might shift from one send to another. So that's why repeat tests are so important. And the other thing with repeat tests is you can start seeing a pattern, right? So what we account for in these tests is if a test wins repeatedly, right? So if variation A wins repeatedly against variation B, we will end the test soon. This experiment had 4 different tests inside of it that we pooled, and because B was consistently winning by a margin that was big enough, we could say with enough certainty that this was winning variations, and we didn't need to continue testing it. With other tests, it will be very different, where you will have it will go one way one week and then another way another week, and these are often candidates where we might think, okay, it looked like variation A was winning in the beginning, but actually if we look at this, it seems like no variation is winning. It seems like an inconclusive test, which is also a valid result, right? That's the other thing, is inconclusive doesn't mean the test failed. It just means this particular thing we just tested doesn't matter. And it's a completely valid result to have. So that means that whatever you tested is not something that will get your customers to open or buy or take the action you want them to take. It's irrelevant. So then that means you can confidently move on to something else and not worry about that thing because you've tested it. So this is it. A/B tests are a great idea and they're a great thing to do, and you should absolutely run them. We run them all the time, but you need to do it right, because otherwise you're trusting data that is just a hallucination, right? You're trusting wrong data. So trusting wrong data is the worst thing you can do, because then you stop questioning what you're doing because you think you've done something scientific, and that's false confidence, and so that is very dangerous. So give it the due diligence it needs. Look up some statistical significance tools. You can easily build an Excel sheet, with AI that has the right formulas, and have repeat tests in a way that you can actually trust the results in the end. I will make another video on exactly which tests I've seen work in 2025 and 2026 so far, so you don't waste your time with unnecessary things and you can focus on the most important things.